This is the 13th session on numerical analysis of BSc 5th semester. In this session, we are going to discuss about the new method of solving the nonlinear and transcendental equations, that is known as the secant method. So this is the new method which we are going to discuss in this particular video. Now, in the previous video, we have discussed about the method of false position. That was the method which we discussed in the previous session. We have discussed the method in detail with all the steps involved in the method, and we have tried to solve a couple of examples using that method. In this method, at the end of this method, we will be able to understand what actually the secant method is, what are the steps involved in the secant method, and we will be able to solve a nonlinear equation using this method. So let us start what actually the secant method is and how it works for solving the nonlinear algebraic and transcendental equations. So this method is an improvement over the method of false position. This is an important statement we are doing over here. This method is an improvement over the method of false position. So what we have studied in the previous session, the method of false position, the secant method which we are studying in this particular session is an improvement over that method. So how it is an improved form of the previous method? This is based on omitting the condition. See what new thing we are finding, what improvement we have made in this method compared to the earlier one. In this method, the advantage is that the condition f of a into f of b less than 0. That is nothing but we were using the condition that f of a and f of b must be of opposite sign in the earlier two methods. Bisection method as well as in the regular falsy method, we were looking at this condition, and then only we were applying the formula of those two methods. But in this method, this condition is not at all imposed. So we are not actually going to check this condition, that is f of a into f of b less than 0. This condition need not be checked as far as the secant method is concerned. Thus, at each iteration, it is not necessary that the interval a to b must contain a root. We not necessarily go for checking this particular condition, and we are not going to check that whether the root lies in this interval or not. We have to apply the iterative formula. The iterative formula is very simple. Again, this is the iterative formula we are having. X at the I plus 1th iteration, where I, you can observe, I is 2, 3, 4 like that. So if we substitute 2 here, you will get x3. So x1, x2 values you need. So whatever a and b we have in hand, they have to be taken as x1 and x2. A is x1, b is x2. Initial approximations, they have to be named as x1 and x2. Start with those two initial approximations, find out x3 here. x3 is equal to x2, the previous iterated value, that is the previous value x2. By putting 2 equal to 3, we get x3 here, x2 here, x3 equal to x2 plus x2 minus x1 divided by f of x2 minus f of x1 into f of x2. This is the iterative formula. For the third step, you are substituting the first value, that is I equal to 2. For the next step, when you substitute I equal to 3, you will get x4. So likewise, the same iterative formula is going to give us successive approximations to the desired root. So you continue the process until and unless you get the desired solution up to the desired accuracy. So one more important note we have to observe here, that this method converges much faster than regular falsy method. So what is meant by convergent method? What is meant by the method converges? The method converges means the method is going to give us the desired solution in relatively lesser number of iterations. So that means the method converges faster. So faster convergent method is one which gives us the solution up to the desired accuracy in lesser number of iterations. So as compared to regular falsy method or even bisection method, secant method is going to give us the desired solution in relatively lesser number of iterations. So this is how the secant method works. So now let us consider the first example based on this secant method, that is secant method. So the first example here is to solve this algebraic equation. So what is the algebraic equation here? Here the algebraic equation given is this thing: x cube minus x square minus 2 equal to 0, and the interval given is 2, 3. So this is A and this is B. So we have to take these two values as x1, x2 as far as this method is concerned, and whatever LHS is there, the LHS of the given equation, that we have to take it as f of x. That's what we have done here. You please observe. This is f of x. We have taken the LHS of the given equation, and x1 as the first value, x2 as the second value. So now we will find out what is f of x1, f of x2. We don't bother about this condition, that is whether these two are of opposite sign or not. We are not going to make any conclusion here because we don't at all require this thing. Therefore we don't bother. Simply we find out f of x1, f of x2. After finding f of x1, f of x2, we use the iteration formula. The iteration formula is here. You please look at this formula, and in this iteration formula, I equal to 2, 3, 4, dot, dot, dot. If you go on substituting, you will get the values of the x3, x4, x5, like that. So what happens when you substitute I equal to 2? When you substitute when I equal to 2 in this equation, I am calling this formula as equation number 2. In equation number 2, you please look at this. This equation itself is taken as equation 2. The formula itself is taken as equation number 2, and for I equal to 2 in equation number 2, we get I equal to 2. If you substitute 2 plus 1, that is going to be 3. So x3 value you are going to get. Wherever I is there, if you put 2, it is x2. It becomes plus sign as it is. It is x2 minus as it is x2 minus 1, that is x1, divided by it is f of x1. See, you please look at this. The first here it is x2 minus x1 in the numerator, whereas in the denominator it is f of x1 minus x2, f of x2. So f of x1 minus f of x2 into f of x2. So this is the formula we have written as far as x2 and x3 are concerned. And now let us substitute their values. x2 is in our hand, x1 is in our hand, f of x1 we have computed, f of x2 we have computed. Let us substitute each one of them as this, and if you simplify the right hand side, the value of x3 turns out to be 1.5. So this is the first value we have obtained. The given data was 1, 2. Starting with the initial approximation 1, 2. 1 was initial, 2 was its improved, and now we got 1.5 as x3. Now with this value of x3, let us move on to the next step, that is we will use the same formula which I have shown you over here. This formula we will use, that is equation number 2. I called it as the same formula with I equal to 3. So what happens to that? If you look at this, for I equal to 2, for I equal to 3, equation number 2 implies x4 equal to x3 plus x3 minus x2 divided by f of x2 minus f of x3 into f of x3. You please carefully look at this equation, that is equation number 2. Once again I attract your attention here. You please look at this equation. This is equation number 2. We will be using this equation itself everywhere in each step with new values of I. In this first step we use I equal to 2. In the next step we are using I equal to 3. The same expression with I equal to 3 is giving us x4. So what is that x4? You please see. x4 is here. x4 is here given by this. This is again by the same equation 2. with I replaced by 3. So we got this thing. Here we need f of x3. F of x2 is already in our hand. F of x3 we need. Therefore, I request you people to get it calculated. Therefore, immediately after getting the value of x3, it is better if you calculate it f of x3 and keep it ready. So that value we are having here in above this line, and we are substituting that value over here, and we are getting this right hand side. And if we simplify this right hand side with our calculator, the value of x4 is equal to 1.6522. We have observed that x3 was 1.5, now x4 is 1.6522. So we have to proceed further. Now we have to use the same formula, that is which is displayed in equation 2 in the previous slide, with I equal to 4. In the previous it was I equal to 3, now it is I equal to 4. With I equal to 4, the same equation gives us x5, that is the fifth approximated value of x. So x5 we are going to get like this, and here we need f of x4. We have calculated x4, we need f of x4, therefore keep it ready. For that purpose itself, I have calculated that value over here, f of x4. Immediately after getting this, if you go for finding f of x4 in the expression of f, what is f of x? Wherever x is there, if you replace it by x4, that is 1.6522, and if you simplify the right hand side using your calculator, you will get the answer minus 0.2196. So you substitute this value here in place of this, and as well as in place of this, and this will be the right hand side. If you simplify the right hand side, the value of x5 we are going to get here is 1.7032. So x4 was 1.6, x5 is 1.7, therefore we have to proceed. So you please proceed to the next iteration, find f of x5 and use the same equation number 2, and the formula is here for x6 with I equal to 5. For I equal to 5, equation 2 implies x6 value, x6 with x6 as represented by this. If you simplify this, x6 is going to be the new value, that is 1.69. It was 1.7 in the previous step, now it is 1.69 again. Therefore we have to proceed. So please go on proceeding like that for the next iteration, that is the same equation with I equal to, the same formula with I equal to 2. The formula number 2 with I equal to 6. If you replace I equal to 6 in equation number 2, in formula number 2, you will get the x7 value. x7 value by this formula, f of 6 you need, x6 you have already obtained, f of x6 you compute, and you will get the answer as this much, and you substitute it over here, and after substituting and after simplifying the right hand side, the value of x7 is going to be 1.6956. So you please observe the two values which we obtain in the previous iteration and this iteration. How many iterations we have done? This is the first one, I equal to 2, I equal to 3 the second iteration, I equal to 4 the fifth one, I equal to 5 the fifth one, and I equal to 6 the sixth one. So these many steps we have elapsed, and now you please observe x6 was 1.695, that is up to 3 decimal places. If you look at the answer, x6 is 1.6954, and here x7 is again 1.695 up to 3 decimal places. The two answers x6 and x7 are correct. x6 and x7 are same up to 3 decimal places, and hence we can conclude that whatever answer we get in this step, that is the final answer. So this is our conclusion. The required solution is 1.6956. Therefore In this way, the secant method works for all type of nonlinear algebraic and transcendental equations very effectively, and it converges much faster than the earlier two methods. Therefore, this is a great improvement over the earlier two methods. So I hope you understood very well the procedure involved in this method. So with this, let me conclude, and I attract your attention towards one example that you can solve later on by yourself as the homework. Please try to solve this problem. This is the assignment problem for you. Please look at this problem and try to solve this by using the secant method. This is the assignment question to you. Using the secant method, find the real positive root of this algebraic nonlinear equation in this interval 2.5 to 3. They take this as x. They take this as x1. This as x1 and this as x2, and this as f of x, this entire thing as f of x, and if you perform couple of iterations, you will get the answer as 2.706. So this is the final answer after few steps by applying the same secant method formula. So I think you can very easily do it. If you have any doubt, please refer my book which is here. So with this, let me conclude. Thank you very much.